There you go.
Okay. Yeah, so now it's already 8:03 and let's just get started, okay?
Okay.
Yeah, we have 11 so far. Yeah. Okay.
Yeah,
Hi
good to
guys.
go.
Okay, good morning, good afternoon, good evening to all of you joining us from around the world. And welcome to our Realsee webinar today. I am Tanya, Director of IT Solutions at Realsee Technology USA. And today's webinar is a continuation of a very popular webinar. It's called From Realsee Point Cloud to BIM using Revit. And our host, Gabriel Alaka, will be showing us more of his expertise and insight. And in addition to this, he will also showcase some of his renowned water feature projects. So without further ado, let's welcome Gabriel. Gabriel, let's get started.
Awesome, awesome. Hi, guys. Let me just share my screen. I think I have to send a request. There you go. I'll just share my entire screen. Let me minimize some stuff. I'll just keep it open like this. Okay. Um, so as Tanya mentioned, this is gonna be a part two of a webinar, and I'm going to be concentrating on best practices for point cloud to BIM conversion, primarily using Revit. So long story short, I'm going to be showing you how to create as-built drawings. But this is the same slide from last time, just a little bit about me. Um, Right now, I'm in Los Angeles, and my main job is that I'm a project architect at a company called WET, which I'm going to show you a few of my projects. Because what I do at WET is I put together construction documents for contractors and builders. So that's kind of what I do on a daily basis. So I've been, using the Realsee platform to essentially scan existing spaces to get some as-built drawings out of it, because you always need to start with something instead of a blank sheet of paper. Just a little bit about WET. So this is my full-time job. Uh, I started a side business back in March. So on the side, I do as-built generation with Realsee and the Galois camera. But on my day-to-day, I'm a full-time project architect at WET. And WET is actually an acronym. It stands for Water, Entertainment, and Technology. And the company has been around for over 40 years. And we're comprised of many, many people. We have designers, architects, illustrators, videographers, engineers, choreographers, machinists, field techs. Um, and I'm talking about hundreds of people. And we've designed many water features around the world. You can always visit our website at wetdesign.com to see more pictures and things of that nature. I'll show you some photos, but I have personally been with the company since 2013 as an architect. And as I mentioned, I take part in project documentation and producing construction documents. So I'm not really involved on the design side of things. I'm more on the construction documents and, putting pen to paper, and dealing with contractors and things of that nature. So since that's what I do on a daily basis, I know a thing or two about best practices, and that's kind of what today's topic is related to. Even though I'm talking about Realsee, I'm in this world every single day in AutoCAD, Revit, and things of that nature. So I kind of wanted to show you the best way to go about documenting or just using those softwares. And another thing I can say is I can only talk about projects that are already completed at WET. I cannot discuss anything that's in the works or ongoing. We have non-disclosure agreements and things of that nature. So everything I'm showing you here is things you can probably find online. So I'm on this screen. I'm showing two projects that we finished already. The one on the left is in Dubai. It's called Expo 2020. And the one on the right is in Singapore. It's the Jewel Airport. um, Terminal 1 to 4, something like that. I worked on the one on the left, not so much on the one on the right. Just to give you a quick, I just found a random video online. I'll just press play. It might be a little stagnant on the screen, or I can just copy and paste this, I guess, into the chat. If you guys want to take a look at these, where is the chat?
The chat.
I can't find my little
It's right
screen.
besides the React
Oh, there it is, chat.
participant.
So
Yes.
I just found this. This is a random video that I found online for this one. I'll just play a few seconds of it.
Wow. So this is like slideshow.
Yeah, so this is I'm just showing a little video. You guys can click on the link and watch the whole thing.
Mm-hmm.
So that's a project, but we have many types of projects. We also did the one, this is before my time, the one at Burj Khalifa, at the base of Burj Khalifa, the dancing fountain. The Bellagio fountain is from Wet. This is another one called Americana. This is in Los Angeles. The one on the bottom left, this is in the Philippines. It's called Sakura. It's a dancing fountain. This is another one at the bottom right. That's at an airport. So they have a very big library of projects. Let me send you another link. This is our website. It's just wetdesign.com.
Mm-hmm.
Again, I lost the chat. There it is.
Everything
Too
about
many,
water.
too many screens. Yeah, everything is about water.
Yeah, just not showers.
Yeah, no showering here. Um, and then just as an
Wow.
extra bonus, I'll send you guys there's a hyperlapse video of a project. It's not gonna work. I think if I play it on Zoom, it's probably
Mm.
not gonna look any good because it's a hyperlapse video. This is another public video of a project that I did. This was is in Chicago. I could try and play. Let's see what happens. This is a hyperlapse of a whole video. So this is the stage of the project that I'm kind of involved in, during construction. We already have the drawing set, and then we work with the contractor to get it built.
And during the process, do you also use any type of scanners to record the process?
Not yet, but I think we're gonna start doing that at some point. This is kind of a new territory. The use of LiDAR scanning is fairly new
Mm-hmm.
to the AEC industry. So I think this is one of those things that is going to start being used more and more often now, especially if you can do it quickly and on the fly. But yeah, I'm trying to get this involved in my daily life at WET as well.
Yeah.
So because it's very beneficial. So I think I already put a link to this in the chat because I'm
Yeah.
pretty sure it's probably just I don't know how it's going to be on Zoom. I'm guessing it's like skipping around and not that smooth. So you can just watch it on your own time. But I put the link in the chat. Um, so one thing that because I met Tanya a few weeks ago, and then I found out that their headquarters for Realsee is in Beijing. And I actually did a project in Beijing that, I mean, we call it here, what we call it Kafka. So these are the design drawings for that project from a while back. And this project is already built. It's been there for several years. But this is the kind of stuff that I don't work on. I don't do design drawings such as this. I don't do animations, of that nature. Essentially, this is what our very talented designers put together. So this is the project. It's two ribbons that are hanging inside of an atrium in an office building in Beijing. So the project is actually inside of this atrium you see on the left, and it looks something like this. And then it's basically two sheets of water coming down from the almost, I guess, ceiling of this really, really tall atrium. So the kind of stuff that I do, which are architectural drawings, they look something like this. They're, black and white drawings with dimensions, call outs, section cuts, very detailed drawings at different scales, different sizes. And of course, now we also do 3D modeling of such things. And my own personal choice of software for doing all this is Revit. It's become an industry standard, and that's Revit by Autodesk. They're the same people who make AutoCAD. This is just showing you just a sneak peek of what an architectural drawing might look like. They just have a lot more detail on callouts and things like that. So this is kind of like my area of work, and that's kind of what I'm going to be showing you today, of how to make such drawings to the best that I can. And then this is the final project in Beijing. Yeah, see, we call it Kafka, but it looks like this. That's inside the atrium. That's when it's lit up at night. And we actually got a Guinness record for this, for the longest mesh or continuous mesh from top to bottom. Because this thing was a very, very, I think it was like 60 meters tall. Or it was tall. It was very tall. The benefit of Revit is that you can be as detailed or as not detailed as you want to be. So this is another project. This one is in Qingdao.
Oh, China. Yeah, also in China.
It's an inside of a hotel lobby. It's a small water feature, but a very, very sophisticated water feature. And this is just showing you the capabilities of what you can do in Revit. This is essentially a 3D model it's called an exploded axonometric. So it's just like kind of pulling up all the pieces, before you kind of squash them down together, which is shown on the very right side. So you can get very creative in these softwares. What's up?
So I have a question. So all these it's not from point cloud. I mean,
No,
from point cloud that this is from scratch.
this is from scratch. Yeah, there's no point cloud here. Like in situations like this, we'll get drawings of the building, because sometimes the building is still being built. So we'll have drawings from, just structural drawings, electrical drawings, things like that. The beauty of Realsee is that if you're working in an existing space, you would use the point cloud to generate drawings of what's there today. Where's the column located, where's the wall located, things of that nature. Which is kind of what I'll be showing you in a little bit. So this webinar is essentially, as Tanya mentioned, this is part 2. And I'm going to assume that you've already scanned your project and you already have an RCP file or an RCS file that is ready for integration into Revit. If you haven't seen part 1, it's on YouTube. It's also, you can ask anyone on the WhatsApp group. We'll send you a link so you can watch part 1. Feel free to ask me any questions during the presentation. Interrupt me. You don't need to wait until the very end. You can also still send me an email to gabriel@glockarchitects.com, and I can share this PDF that I'm showing you right now with you, or another PDF, because it kind of has some hyperlinks in it. Also, I can be rather fast when I show things, so if I go too fast, let me know and I'll slow down, or I'll repeat something. My preferred software for project documentation, as I mentioned, is Revit. Today I'll be showing you Revit 2023, but it doesn't really matter which version you use. That's just the one that I'm going to be showing you today. In this industry, you kind of have to have all versions of Revit installed on your computer, because every project lives in a different version of Revit, and it's not backwards compatible. So you can only forward upgrade, but not downgrade. So I have projects in 2022, 2023, 2024, 2025, so I have all Revit installed on my computer. I'm also going to be showing you a little bit of AutoCAD. I'm not going to be going this of the camera, because that was already covered by James Heck. He did a webinar back in the days. However, I am assuming that your building has to be scanned inside and outside. Otherwise, you won't get the thickness of the wall on the outside. So you need to scan both the inside of the building and the outside of the building. And it's up to you how far out you want to go. And today I'm going to be showing you the as-built documentation of a project that I did of a commercial building. It looks like, how do I move this? I'm going to show you this one. This,
Uh, I have a question. I don't know much about architecture, but I want to ask you, when do we use BIM and when do we use as-built?
so as built just means that you have no drawings of what's there. So basically it's a blank sheet of paper. So if let's say someone wanted to remodel their house or do something to a building, the first thing that any architect is going to ask you is, well, I need to see some drawings. So what they would do is they would send someone over to the site, and someone needs to sit down and measure all the walls, the doors, the windows, and then essentially go back into it could be AutoCAD, it could be ArchiCAD, it can be Revit, whatever it is, and someone's got to sit there and draw walls, windows, doors, curbs, all that kind of stuff to then give an architect a starting point of a drawing that shows here is your house. So that's why it's called as built, because it's showing the existing conditions. So
Mm,
BIM just means building information modeling, because um, Revit doesn't draw lines, it draws actual walls, windows, doors. So everything can be quantified. So you're not just drawing lines in a drafting software, but once you build a model of something in Revit or in BIM, that that building is quantifiable. So you could give it to a contractor, and just based on the BIM model, they can say like, okay, this project needs, you know, 6 tons of concrete, or it has, this many yards of lumber, or because everything is quantifiable. You can schedule everything. You can create it's basically a very detailed look at a building. Um, and the beauty of the Realsee is that, you don't take any measurements. You just scan the whole building, and then you just drop it into the software, and then you use that as your guide to then build a model on top of it. You the the point cloud model by itself, you really can't do much with it, because you're just using it as a background to almost, like, I guess you can say, like, trace over, because everything is already pre-measured. You're looking at the building in real time. So you know exactly where each wall is, how thick it is. So then you just basically in Revit, you draw over it of the
mm,
location of all those objects, and then you create. So I'll show you what an as-built drawing looks like.
mm-hmm.
Um, let me see what's my next slide. I think I'm almost towards the end. Oh, this is just my typical setup. Um, I just
You
have
also have the Realsee package there.
oh yeah, I still have that's the one that I got. I also have an extension if I want to go a little bit higher, but this is just
Wow.
my typical setup that I use.
How
Um,
high is the one on the right? You
it's
put
it's an
Realsee.
extra it's an extra meter,
Oh,
a
I
meter
see.
from here to here. However, once you go this high, it's important to use the ultra density one. That way, it rotates very slowly. Because if you use a standard rotation for this one, it starts to swivel. It starts
Oh,
to
very
shake a
good
little bit.
point.
So if you go
Very, very
really,
good.
really slow, it almost stays still.
Ah,
But I use this not that often, but because this one captures better roof eaves and roof pitches and things like that, if you need
mm,
to. But
okay.
I for the most part I use scans like this on the left.
Mm,
Um, so so to get started, so I'm gonna start with the end. I'm gonna show you. This is so I did this a few weeks ago. So this is essentially a drawing package. Right now, this is just 8 pages long, and it just shows. So this is the BIM model, what it looks like. This is the final result.
mm-hmm.
It's got CMU walls, it's got fences, it's got some wood siding, it's got garage doors, it's got bricks, it's got plaster, et cetera, et cetera. Um, this is a roof plan of that same building at North, and I'm going to kind of show you how some of this was done. And then this is a floor plan of that building. So, it's got walls, it's got some, restrooms, sinks, It's got some square footages, column locations, grid lines, and then obviously it has some section cuts, some elevations, but this is just like, just a base plan. Then this is called an RCP, or a reflected ceiling plan. So now you're looking up at the ceiling, so you can tell that there's some hanging lights in some locations. There's some ceiling fans. There's a T-bar ceiling. There's some fluorescent lights. There's gypsum ceiling, another fan. This building has no ceiling, so this is called an RCP. And again, all this is extracted from the point cloud, or the point cloud was used to find the locations of these things. And then here's some elevations from the outside, front elevation, back elevation, east elevation, west elevation, and then you have sections. So now this is a slice through the building that shows the different wall components. It shows the different ceiling components, how the way the roof looks like. So all this is, again, this is a very smart model. All this is extracted from the BIM model. See, there's some trusses, things like that. So all these things, like this 6-inch step that goes up and down, all this was very, very clearly visible from the point cloud model itself.
Hi, Eric, I have a question for you.
Mm-hmm.
And I saw you have some roof plan. And how do you get that roof plan from the point cloud? Because I know the camera is not that tall to reach the
Exactly.
roof.
Good point. So for that, honestly, I use Google Earth.
Okay. Okay.
I
Okay.
look
Yeah.
at the building in Google Earth to get an
Okay.
idea of
Okay.
the roof. Yeah. In a perfect world, I would get on the roof and do some scans there, but
Oh,
that's
oh,
too much work.
or maybe drone. Or maybe
Or a
drone.
drone, yeah.
Drone. Yeah.
If I
Okay.
get a
Okay.
LiDAR drone, that'd be even awesome.
Yeah, yeah, that's another thing. I'm looking at like a LiDAR drone, but I don't
Correct.
see anywhere. That will be the next thing, no?
Correct.
Okay, no,
Correct.
thanks. Okay, thank
But
you.
but 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 like for a house, if as long as I get the pitch of the roof, like for example, like here, I was able to get this pitch from this elevation, and then I can just kind of extrude it down the line. But you're right, you can't see the roof, so the roof
Can I
has to
say
be a
something?
little bit of investigative work. Yeah.
What about photogrammetry?
Photogrammetry, it's because you need such precision. I've never because I think it's how are you gonna get up there? Like if the camera can't see the roof, how are you gonna do
Oh
that?
no,
Like you never saw it.
photogrammetry is done with my drone. It flies over and it
Uh,
takes multiple photographs.
yes, yes,
That's
but it requires a drone. It definitely requires a drone. Yeah, if I had a drone and I could see even a picture of the roof would be very helpful. But yeah, you're right, you could do that too. But the only thing is, but
I,
that's not a point cloud.
I would just add that Google Earth is photogrammetry, is derived from photogrammetry.
Yes,
Yeah.
yes. And it gives you a rough idea, but in reality, the best solution is to also scan, that outside portion of the roof. If I could take the Galo camera on a drone and lift it up like, 50 feet and take a scan, that'd be awesome. But
Yes,
unfortunately, I
that's
can't
what
do
I'm. Yeah, that's what I'm thinking. I saw your extension, but if you can get like a little bit long extension to reach that one.
it. That'd be wouldn't that be nice? Um, so yeah, so how do I start this process? So the first thing or the place that I always start is I always start with essentially creating site context. So I personally always start in AutoCAD, and then I try and find two things. The first thing is just where is it? I start with a very typical Google Earth view of the project. In this case, it's like right here. This is the project right here. And on Google Earth, the bottom right corner, there's always going to be a little scale bar right here. At the bottom right corner, it says 20 feet right here. But it's very rough. I mean, I don't trust that, but it just gives you a pretty good idea of what that is. And then second from that is from your own city general maps department, you want to find a parcel map, which looks something like this. And this will give you, again, you're talking to an architect here. This will give you, basically your property line dimensions. In this case, 50 feet. This is all in feet. 76.76 feet. Here's the radius. It kind of goes around. So with these two drawings together, you can kind of start to understand the context of the building, because again, you don't want to just model the building and just have it float in the middle of nowhere. You need to give it some kind of a context, because especially if you're doing, let's say, a house, you want to deal with setbacks. You want to know how far are you from the setback, because again, you need those lines to be part of your drawing. That way you don't just have a building floating on a blank sheet of paper with no context around it. So all of this starts in for me, it's an AutoCAD. So in AutoCAD, the first thing you do is you're essentially going to import, and I'll show it to you live. So I'm just going to go to attach image. So I'm going to I want to start with the Google Earth photo. And I'm going to be really, really fast here for a little bit. So when this image comes in, it's going to be really, really tiny, or as big as you need to be. So this, I can make this all day long like that. So the first thing you need to do is essentially scale this drawing to the right dimension. So in this one, for example, I'm going to draw what 20 feet looks like. I don't know if you guys can see that on my screen. I'm going to make this image a little faint. That way you can see what I'm doing. So this blue line is 20 feet. So now I'm gonna basically take this drawing and basically bring it down like that. So now I've basically made this drawing so that way this line is 20 feet. So if I list this line, you'll see it's 20 foot. So I've scaled this image, and then this image gives me an orientation of the building. It's also important that you draw this a true north. So north is exactly up, and this will start to define north elevation, east elevation, west and south elevation. So after you do this, you do the exact same thing with the parcel map. So again, I bring this one in. Now, when it comes to, so this is the one that's more accurate. The Google Earth one is very rough. It just kind of gives you a rough idea of the location of the curb, maybe trees, stuff like that. The one that has to be more accurate is your parcel map. So on your parcel map, you see there's no what do you call this? Like a scale. There's no scale bar on this, but there are dimensions on it. So what I typically do is, I'm gonna make this a little more faint. What I typically do is I try and find the longest dimension I can possibly find. So in this case, instead of scaling this drawing based on 50 feet, I'm gonna find like this one right here, 159.79. So if there was a 300-foot dimension or a 500-foot dimension, I'll use that one. But I try and find the one that has the longest possible dimension. So in this case, I'll do this one and I'll scale the drawing to this dimension. And then I'm going to just kind of skip ahead here. And I trace a few elements. So I've traced over the lines from the property line. So these purple lines are exactly what's shown on that property, on that survey. And I've roughly outlined the building based on Google Earth. So using those two, I've created a very, very rough site context drawing. And again, it's very important to have this oriented north, because as an architect you need to know, because the sun does this every single day. It starts in the east and then sets in the west, which means that this part of your building gets the most sun. So if you're gonna put solar panels or whatever, it's important to know which way is true north. Because in Revit, I'll show you later, your site plan is always in true north, but then your architectural plans are always going to be orthogonal. What I mean by that is that you can see how this is at a slight angle, but in reality, in reality, your floor plans are going to be exactly like 90 degrees. And I'll show that to you in Revit in a little bit. Everything is going to be like rotated a little bit. So, so this is the first thing that I ever do. I just establish something very rough like this, and then I bring this into Revit. Any questions on this before I go back? I go into Revit from anyone?
Alaka, I think yeah, the way the process you show how to get the partial and the Google Map in AutoCAD, there is a very precise and a very quick with method, and you don't have to go that way scaling. And I don't know, it's a good time to explain to you, but there's a very shortcut, very fast method. We use it. I'm a civil engineer. I practice as MP, and I do
Okay.
the civil, and I do most of time, and we can do the whole thing in very about few minutes, and
Oh,
precisely. I can share with you, and I just you don't have to import those my my pen thing.
I would love to learn anything that can get me a little quicker. I'm all for that.
Yeah,
Yeah, maybe
yeah,
you can message me and then we could talk more detail about that.
yeah, yeah.
I'd love to hear about that.
Yeah, it's just it's called we can get the shape file. You can import the shape file, and then georeference. With the georeference, you can get the Google Map background. It automatically come together.
Nice.
Yeah,
Okay,
yeah.
that's good. That's good to know.
Only thing is you want to know your state plane coordinate system, and
Correct.
that if you know that one, then you can get a real coordinate too.
Perfect.
Yeah, Gabriel.
Mhm.
Egil asked a question. Egil said, great workflow, but how can we get the partial map from
Municipal. So
municipality side
I think
without authorization? Without authorization.
I can answer that question. I do that all the time, and every county, every city, every township, and
but
they
he's in
have
Albania. But he's in
yeah.
Albania. That's the
Huh?
issue.
Huh?
He's from Albania.
Oh, Albania, but there is a okay, Albania. Okay, I think I don't know. I'm sorry, but I don't know how
Yeah.
in that area. But there is another different third party software. I can
Ah,
share that one too, and I use. They, I believe they have pretty much all over the country,
uh-huh.
partial boundaries, and each partial boundary, I think they you need order at least 10, but one is about like a 10 cents or something like that for one partial boundary, and I use one third party software, but I can share that one too. But I don't know. I'm sorry about that. I don't know
Yeah.
your area. Okay.
Yeah, here in the United States, it's very easy for us. I mean, we use something called Zimas, and honestly, all you do is you type in an address and a street name, and I can find a parcel in 5 seconds. But again, this is for Los Angeles. So anything again, this is for LA. So in this particular area, most of our cities have this information online. In this case, it's called Zimas. Different states have different websites for that kind of stuff, but I am the most familiar with obviously places around me.
So this is all public.
It's public
Public
information.
information.
Yeah,
Okay.
it's public information.
I looked online and there's an Albania land and property where
Yeah, so
you could get
look,
land deeds and
yeah, you can look up something called an APN. That's another thing to look at, or just parcel. Let me see what it says here, because it's called an APN or a proper, yeah, an assessor. Yeah, look up this word. It's an assessor's map in Albania, or look up APN, assessor's map, parcel map. Um, it just so happens that we have this publicly available online. I'm not sure how different countries do it. So let me just jump. I'm gonna jump into Revit for a little bit. So this is that exact same building that I was showing you. And obviously now you can see the point cloud scan underneath. With some of the walls, I just picked the color red to just kind of show you that, you know, as I was explaining to Tanya, I used the point cloud to then draw walls, doors, windows, literally over it. And just because the scan is so accurate, I know exactly where everything is located. And then when this is all said and done, I turn off the cloud, and I'm left with, you know, the walls, windows, doors, ceilings, and roofs. And this is why, you know, it is such a valuable thing to use an as-built point cloud, or sorry, a point cloud model to create as-built drawings.
This is important because no building is constructed as it's drawn on the plans. That's why you need the as-built.
Exactly. And in the construction industry, when you design a project and you have drawings for the contractor, when the contractor takes over, they don't have to build it exactly the way that you drew it, because they're always going to make changes, and changes happen all the time. So by the time that the project is done, the actual building would no longer look exactly like the actual plans from like several years ago. So even on a contractor's side, at the very end, some big projects require the contractor to submit as-built drawings. So at the very end, I mean, again, and this is most likely with the use of point clouds, a lot of contractors, they'll go around, they'll scan the entire building and then create new drawings to give to the client of the as-built conditions. Because as I said, drawings change through construction. A lot of things change, and then nobody changes the plans, because everything gets captured by the contractor. So then you need a new set of drawings at the very end, which is what as-builts are.
Plus, a lot of property owners build things that aren't permitted, so there's no record of them.
Yeah, so let me show you guys how I got to this point. So this is just the end result of what happens. So I'm gonna start with a fresh drawing. So this is my own template that I've been developing for many years in Revit. And every time I do a new project, I just keep expanding and expanding my library. So what I mean by that is that my template has a lot of things and objects, components loaded into it already. That way, I'm not like looking online for like maybe I have to find a barn door or a pocket door or some kind of like hexagon window or a circular window, because by default, Revit doesn't come, it's kind of empty, so to speak. But there's a lot of people online who build models of different things. And so, throughout my time working in Revit, I've been gathering components, solar panels, whatever it is, and I just keep adding them to my template. That way, when I'm doing my project documentation, I already have everything that I need, and I don't need to spend time online trying to find additional, information. Also, my template that I have is designed in such a way that I've already pre-populated sheets for as-built conditions, demolition, and remodel. And going back to BIM, Revit is a very smart software because you can phase things. So in Revit, I can actually I can model the building in its existing condition, and that's going to be called the existing phase. And then I can actually demolish walls. So I can say, demolish this wall, demolish that wall. And then if I change my phase, those walls will disappear as if I'm actually like, demolishing it. So Revit keeps track of and I'll kind of show you a quick snippet of what that looks like in a little bit. But as I start trying to say, so I have all these like, drawings just kind of waiting for me. So I have all these views that are set up. Because one of the things about Revit is that setting up your sheets takes a long time. So once you do it one time, you make a template, and then from now on, everything is almost like pre-populated. But out of the box, Revit doesn't really look like this. So this is something that you have to develop over time. The first time will probably be the most painful time, but every time after that, it makes it easier and easier and easier. This is many years of work to get to this point where I have everything already pre-populated. And I'm talking like, even stuff like, things like this, notes for construction, like things of that nature, like, what to do with like, garages, egress, hazards, notes. This is just things that I've been working on over the years that I've just been saving and saving and saving to reuse down the line. So how do I start my project? Well, the first thing is to bring in the point cloud. So I have a view here at the very top, which is obviously blank because there's nothing in this drawing. And because Revit is so smart, the phase on this, here on the left, there's a phase filter in the phase existing. So yeah, you have two phases. You have existing and you have new construction. So I'm obviously going to start in existing. Unless I'm doing a brand new project, then I'll switch this to like, new construction. But in this case, I'm doing existing. So now I'm going to bring in the point cloud model.
Mm.
So I'm going to go to insert and I'm going to say link point cloud. There's a whole button just for point cloud.
Mm.
And I'm going to bring in this one. And there it is. I did nothing. It just showed up. It didn't ask me anything about scale, about millimeters, about inches. It just comes in because it knows the units of it. It just popped in. Now once this comes in, I can move this around very freely. So this is millions of points, but Revit has really optimized it, and it's really fast to kind of move it around the screen with very with ease. At some point, once I'm okay with where it's located, I'm gonna lock it and pin it. But for now, I'm gonna just show you, how easy it is to move it around. Another thing about Revit is that you can create something called a section box. And all that is it's just it's this little box that goes around. And if I move this, I'm cutting through the point cloud.
Mm.
I can move this here, and now I'm looking at a very small piece of look at that. Look how I'm looking at the point cloud right now.
Ah.
So now, can you already see how valuable this is? Where I can play with this, and I can already tell that this goes up at this angle, goes down. There's a ceiling, there's a roof. So it's very powerful. You can see all the heights. You can see the floor is lower here, it's higher here. You can see, you can see a lot of things. And
So
that's a very thin slice. Go ahead.
So how is the quality of our point cloud? Those that you downloaded from our Realsee platform. How good is that?
The quality is awesome. It's
Mm.
I have no complaints with the quality at all.
Mm.
However, the thing about a point cloud is that the closer you zoom in, the worse it gets.
Mm.
Does that make any sense? So at some point when I zoom in, it just starts to look like that. It doesn't make much sense at this point,
Oh.
because I'm running out of points.
Mm-hmm.
But the more I zoom out, the more you can start to understand what's going on. And this is why I like the Galois, because when I'm doing documentation, I like also having a second screen with the actual virtual tour,
Yeah.
where I can see things in full resolution. So then by having one screen with a point cloud and another screen with the virtual tour, I can see everything together. Everything makes sense. Let's say there was a little outlet right here. I might be able to make it out roughly here. Also, I should note that I don't do high ultra density scanning. I do the quick one, the standard one. So maybe if I crank it up to ultra density, it'll be better. But in my honest opinion, I mean, unless I had maybe 6, 7, 10 times the point cloud documentation here, if this could have a lot more points to really make things sharp, that'll be that'll be very beneficial. But for now, I can manage with this and the virtual tour on like a second screen. And then the reason why you kind of have to scan the inside and the outside is because when I'm documenting this later, I'm gonna just let me just pull this down a little bit. When I document this later, let me just lock this for a second because it keeps highlighting it. There you go. This.
I have a quick question for you.
Yes.
You said a virtual tour. How we can get the virtual
ahead.
tour next screen? You said you're
No,
gonna.
I'm just talking about if I have a whole different, I have two monitors.
Oh, okay.
So on one monitor, I'll have my Revit model. Other screen,
Okay.
I'll literally be looking at this.
Oh.
You know what I mean?
Okay.
And then here I can say that, oh, there's a little outlet right there. And then in the point cloud, eventually I'll find it, the location of that. But, you know, again, I think it's just because, you know, I mean, the virtual tour is like 10 billion points. You know what I mean?
I see.
But the point cloud is several million points. You know what I mean?
Yeah.
So by having these two side by side, it makes it a lot easier to understand, you know, what's going on.
Okay. Thank you.
That's all I meant by that, yeah. So the reason why I said to scan the inside and the outside is because obviously you can never understand the thickness of a wall if you only scan the inside. So I need to know where this line is to understand how thick that wall is. You need to be able to scan the entire perimeter of your project. That way you get a double line here afterwards of everything. And you know, and this doesn't lie. You know, you can see exactly what's going on with these walls, all these angles. You know, there's a really thick wall here, you know, et cetera, et cetera.
Do you find it beneficial to scan the outside first and then do the inside?
Honestly, it doesn't matter. I've done it either way. It hasn't been a difference. For this particular project, I want to say how did I start? I think on this project, I started my first scan was right here in front of the door, and I scanned a few points here. Then I went back inside. I did all of here. Then I went inside here. I went outside. I went back inside. I went outside. It doesn't really matter as long as you connect all the points. The sequence has been irrelevant. It doesn't matter where you start. It doesn't matter where you start. It doesn't matter if it's outside or inside. Yeah. So this is what I was trying to tell you earlier is that this is very beneficial because a point cloud model, you can slice it into very, very thin slices and start to understand what you're working with. Because viewing a point cloud like this in its entirety is very hard to work with. You know, it has a lot of information, but it becomes very powerful when you start to slice it and dice it and look at it in very small pieces. So again, all I've done so far is I brought this in. And then the first thing I do is I have to orient this to true north. So in my site plan, I'm going to bring in that CAD file that I showed you earlier. So I'm going to just say link CAD. I'm going to go to this one. So there it is. So here's that drawing that I made earlier. Let me just turn off some layers that I don't need. On this layer. Okay, so here's the one that I scanned earlier. So obviously you can see my point cloud came in looking like this, but obviously I need to rotate this to make it match this orientation of the drawing. And then this particular view orientation is true north. That's very important right here. So the first thing I would do is I need to rotate this. So what I would do is I draw like a temporary line. So here's my temporary line. I just need something as a guide. So there's that one. So I'm gonna put this. Very rough about this. So I'm gonna move this point cloud from like here to that line that I just drew. Can you see that? And I'm gonna just basically rotate this. I'm gonna rotate this from this point. And I'm gonna be really fast about this right now. So like here, and I'm gonna just turn this around and rotate it that way. So now I just rotated this to kind of match this orientation. And as I said, point clouds are hard to work with when you see everything. So it's actually better for me if I was to look at this, if it was like sliced. Let me show you something here real quick.
Okay, we still have 6 minutes, but we have so many questions.
Oh, you do? Okay. Ask me
Answer.
questions.
Yeah. Shana asked that how did you get the the virtual tour like that? Looks so fancy.
This one, this is you gotta ask Realsee. This is this one came out really clean. I don't know.
Yeah.
This is the one I was very surprised. One thing I
Yeah.
noticed is that the less trees you have, the better your scan ends up being. And also the time of day that you scan is very important. So in this case, I like to do my scans between like 11 a.m. and 1 p.m. when the
Oh,
sun is at its highest point.
oh, I see.
Because then you're less likely to cast long shadows on the ground and everything gets a little more bright.
Yeah. I usually start scanning around 6:30 when the sun,
6:30 p.m. or a.m.
8 a.m.
Oh, really? Oh, no, I like to go when the sun is at its highest position.
Oh,
So that's me. That's me.
okay. And Manny, can you ask your own question here?
Yeah, sure, Tanya. I'm sort of new to this, so forgive me. I'm learning obviously from what you're presenting and finding it very interesting. I was at a client's premises yesterday, and they told me that they had a 4-story derelict building that's going to be totally gutted inside and refurbished. And she said she was already talking to architects. And I've just had an idea that I could go into this derelict building and scan this 4-story building, create a point cloud, and sell that point cloud to the architects. Do you think that's possible?
Absolutely.
Yeah.
Absolutely.
Yeah.
It'll give them a great starting point. I mean, there's a whole business of people because as an architect, the first thing they want to do is they find people who can create as-built drawings for them. That's the first thing. I mean, they would rather get the drawings than the point cloud, but a point cloud is a great first step.
Yeah. But
You
do
know,
you know how much that he should charge for this? Do you have the price?
how much to charge for the scanning or for the
No, for the point cloud.
for the point cloud? You can charge anything you want.
Ah.
Okay.
Whatever you can get.
I mean, I go by square footage, to be honest with you. So for something like this, like $2,000, $3,000, $4,000, something like that, it just
Wow.
depends.
Okay.
Depends on the size, things like that.
Okay.
Because as-builts are very, very, very important. Very
Hi,
important.
Cecil.
Right.
You heard that, Cecil?
Yes.
You can scan a building and sell them the point point
Yes.
cloud.
And
Okay, so the problem I had is when I approached the architect wanted dimension lines. He wanted, he did, because right now they say they go out and they take photographs of the building. They're going to do a building. They go out and take photographs and take their own measurements. And they want to know what I was going to offer beyond that. So when I say that all I can offer is a floor plan with a general area, they said that's not adequate enough. They wanted to know. They wanted to know what the windows are, the doors are, with dimension lines and so forth. If they could get that, then they'd be interested.
Yes, but the point cloud is not going to give them that information.
Correct.
Right?
That's what they're saying. They're
Yes.
saying they might as well go out and take measurements with their tape measure themselves.
But if they have an in-house person who uses Revit, just having that point cloud is already beneficial to them.
So they need
I mean,
Revit then.
Yes, in my opinion, yeah. But not just Revit. I mean, from what I've heard from other people, you can do this in ArchiCAD, you can do this in AutoCAD. There's other ways to do it. I just use Revit, But
Well, they
having
have all that, but they're pretty sophisticated. They
Yeah.
have all that, but you know, so but they were saying that what I was offering with just the area, square foot area, wasn't enough. They might as well go out there and still take the measurements themselves. And so that's why I suggested that Realsee work on having the software updated so it could actually give dimension lines. If no,
No, they
not gonna
can't.
happen.
No, not gonna
Okay.
happen because this is, I mean, we're talking about, I mean, it's a very intensive labor. The point cloud does what it needs to do, but it's not gonna build windows and doors and ceilings and floors and things like that for you.
Okay.
It just places the building in 3D in your model in full scale. It's a full scale point cloud model that that can be used for many things. But there's people on in the WhatsApp group, and this is a business to essentially generate as-built drawings for architects to get started on their stuff.
If you
Uh,
took the photo scan, photo scans are accurate enough that you can dimension them.
but it's not an architectural drawing at the end of the day.
That's
So,
true.
so what you need to, so what I need to offer is as built is
You need
basically
as
what I need.
built, but but you also need to be able to do the conversion from, like the part that I was just showing you. Because the point cloud itself depends on the office. If they have in-house people who can build models, then they can make their own as-built drawings, and then all you do is you give them the point cloud model. You see what I mean? But
Mhm.
doing the point cloud model, I mean, you need to have some architectural background to build that. I mean, I didn't go into detail today, but you can go as detailed or as not detailed as you want to make those drawings.
So even just sell them the point cloud, that is not enough. Is that right?
It's step one. It is step one. It just depends on the office. Some
Mhm.
places they might just look for the end result. Like they just want drawings.
I
That's
see.
that's one
Yes.
option. You know what I mean? Another option is like they'll make the drawings themselves.
Ekio has one. Ekio says something here. Said some architects don't know what to do with point clouds. Is it correct?
Yeah, I would say so. It's fairly new in the industry.
I see.
But it's not, I mean, I find it extremely valuable and useful to use this for virtually anything, but it's not something that's being taught at schools, or it's just not that common, but I think it's starting to pick up a lot of steam right now.
I know Akio is an expert in this. He look at the
Yes, it
cloud
definitely
and
is.
then he can do something with the measurement, and he even can come up with BIM like you do.
Yes.
So he knows a lot about this. Okay, so it's already 9:01. Any question here? Or we are going to wrap this up. Any questions?
One last thing. So BIM, you use the word BIM. So once again, is BIM? Are they interested in BIM? Are architects and engineers interested in BIM? A BIM
Are they,
file?
are they are they interested in BIM? No, because even to be honest with you, even with this building, at the end of the day, my deliverable would be, again, it depends on the architect. Most architects don't even work in 3D, but I use 3D to generate the plans, the sections, the elevations, the roof plan, the ceiling plan, all that kind of stuff. So ultimately, and I guess I can show you the final deliverable. Sometimes it's just CAD drawings. Let me see if I can find something real quick, so that way you can kind of see the ultimate end result.
I don't have to see it. You can just tell me what it is. The ultimate deliverable is what?
It's just a CAD plan,
A
like a
CAD
CAD
plan.
drawing.
Okay.
Yeah,
Okay.
the BIM is, I mean, some people might want the BIM model, but this is it right here. This is what architects work with. You see this? You can zoom in. It's basically lines, but this is all extracted from the BIM model. And this is a fully dimensional. See, everything has dimensions. This is a true drawing with real scale. And whether it's a PDF or a BIM file, I just prefer to use Revit to get that out of it. You know what I mean?
Mm.
알리오? 알리오?
Okay.
알리오? 밑에.
Anything else?
Yeah. Okay. Anything else? Any other question? If not, hi, please turn off your microphone.
Yeah, and when it
Okay,
comes to cost,
so
I will say go by square footage.
yeah. Okay, guys, thank you for your participation in this webinar, and we will call. Okay, Manny, you have questions? No? Okay. So we'll wrap up the webinar, and in the meantime, I want to tell you that our next webinar will be about how to get clients for your 3D tour business, because like Cecil, that the other day, he said that he had a really big difficulty getting his clients. So what we'll talk about is your pain points, in expanding your business as a 3D tour creator. So that will be all for today. And the date for our next webinar is not, I haven't decided yet, and I will announce it when it is available. Okay. So thank you guys, and thank you for the heated discussion, and thank you for learning, Gabriel.
You're welcome. You're welcome.
Thank
Thank
you.
you,
Okay.
Good
Gabriel.
talking to you guys.
Okay. Bye, guys.
Any questions?
Bye.
Bye, guys. Bye.